Okay, so ladies and gentlemen, we're going to continue our discussion of importing data, getting data. Yesterday we saw some features of getting data from JSON, and today we're going to go on to CSV and then Cassandra. Okay, Cassandra is a data source. Now, in order to do this, we're going to need to copy some code from that email message I sent you. And maybe what I'll do is ask you, before you paste that into your shell, to do a couple other imports so that you can make use of them. And just so that we're starting at the same place, I'm going to restart my Spark shell. Okay? While I'm doing that, I should note that I did post the items from yesterday, but I did so with a certain degree of flexibility. So as I am wont, I commented things here, but I wanted to emphasize a few points from yesterday. So one point is that yesterday we read things in from JSON, and you may recall that it actually allowed to automatically deduce quite a bit about the so-called schema, the sort of what types things were within the file. But that didn't automatically give us type information for Scala. So in order to impose type information, we used a case class. And this case class needed to have names for the fields that were the same as the names in the data frame that we were going to which we were going to apply this. Okay, so here we go. Like each of these, you may remember that we tried it with different names and it failed. It had problems. Okay, so the idea here is what we were doing is we read in from JSON, and the data frame knew that certain things were doubles, certain things were ints or longs or what have you. But it's a data frame. And a data frame, turns out in Spark 2, is a data set without information about the type of each row. And it would work just fine. In fact, we selected from it, we filtered it, lots of good things. But it didn't have the type information, and sometimes type information is really helpful. One thing it's helpful for is efficiency. Another thing it's helpful for is to avoid mistakes. So we went and we declared a case class. But you'll notice before we declared a case class, or before we applied that case class to this df CCHS selected, I actually selected a subset of columns. Okay? This is a subset of the columns of the entire data set. This is an extremely important pattern that we're going to see again today. Okay? And the important thing to realize is you are not required to create a case class for all of the fields in the original data source. If you had to create a case class for all of the fields in this original data source, it would take a long time. But more to the point, ladies and gentlemen, more to the point, case classes are limited in Scala to up to 22 fields. In the current version of Scala, 2.10, 2.11, I think it applies for 2.12, you cannot have case classes with more than 22 fields. Perhaps not coincidentally, you also can't have tuples with more than 22 items in them. Now, what this means is that if we wanted to declare a case class for all of the fields which are in this original schema, it would at the least be a pain. We have to define a really big case class. And second of all, it might not be possible.
Could you do nested case classes?
Well, yeah. I mean, there's ways to create something, but the problem is it's not going to be able to apply it. as a case class as neatly as it does here.
Right.
Remember, the idea is we just define this case class, and then to turn an untyped data frame, a data frame that doesn't have static knowledge of the fields, into a data set which does. All we have to do is say the data frame dot as this case class. It's a thing of beauty. If you have more than 22 items, you really need more than that. What you can do is you can use what's called it's actually a subclass of something called product, Scala.product. And you have to go define things yourself that are normally defined automatically with case classes, and you can do it. It's not a giant deal, but it's a bit of a pain.
And the reason you can do it here with the as is just because of the pattern matching feature in the case class?
So I'm not sure I'm going to do justice to that, but basically the as allows it to be provided the type information, which is this, to use for each row.
But underneath that, is that kind of a pattern matching thing happening?
Yeah, I think there's a pattern matching thing with matches. I think there's also some bit of reflection going on, which connects each of the fields in the data frame to each of these items here based on its name and that sort of thing. And that can render it then. This is a data set. This is a data set too. Both of these are actually data sets in Spark 2.0. This is a data set, each of whose rows is of type row. This is a data set, each of whose rows is of type this thing. Okay? And that allows it to know about each of these fields in a nice way. And that allows it to undertake certain optimizations. It allows it to allow you to write, nice things that refer explicitly to the fields like this, where it explicitly refers to the fields rather than quoting them and being at risk of an error only being discovered at runtime. Anyway, ladies and gentlemen, now the key point I wanted to make is here, we didn't have to create a case class for this whole darn thing. All the fields, all we did is we created a subset of the fields in which we were interested. And then we defined, that was called df_cchs selected, and then we defined the case class for that subset of fields, and we created a data set from that.
And that's supposed to be started with the JSON file.
Actually, the same pattern we'll use today. Okay, but the JSON file allowed us to have it automatically infer for internal use the types of the data frame, the type of each field in the data frame. So it actually knew, oh, this one's double, this one's big int, or whatever. So it actually did allow it to be used internally. It's just, it's still, all it knew was type row as far as Scala is concerned. Okay. Anyway, so that actually allowed us to avoid some difficulties. Now I want to highlight that once we did that, once we got this data set, we could do nice things with it. And of course, we could still treat it as a data frame. These are data frame operations, sort of these operations here. And actually what came out at the end for some queries is a data frame. Now, with kudos to Aiden, ladies and gentlemen, we can, when we have a data frame, we can do collect and get back an array of the items in the data frame, which would for most untyped data frames is a row. But if it's a data set and we do collect, we'll get back an array of the appropriate type. And then we can take each of those things and do things with it. If it's a row, you can call like get long. This basically says get the first column 0. It goes from 0, 1, 2, 3. It says get it as a long. Okay, so that basically allowed me to sort of turn an array of rows into an array of longs, which is quite nice. Okay. And today we're going to be going through this with the CSV, but you'll find very similar sort of patterns, but with less pleasantry, with less pleasantness, with less, if I may venture, beauty. Okay? but the same basic pattern will apply. Okay? So, ladies and gentlemen, that was just a bit from yesterday, and I did want to note this pattern to which we must credit Iden. There's collect. Turns out collect turns this data frame into an array of whatever rows it is. There's collect as list, which turns it into a list of whatever types of rows it is. So each row of the data frame gets turned into an item in this array, an element of the array. And then here, we take that element and we get the first column in the row, and we extract it as long. Okay? Okay. Great. So that was a bit from yesterday, and I'm going to save that as its own recording because I think it enjoys